Welcome to the session 2 of Unit 2. We are still looking at the tools of economic analysis. Here, we are going to be talking about graphs and concepts of slope. Graphs and concepts of slopes. One of the most powerful ways of conveying statistical information is in the form of graphs. And in your study of economics, you are going to encounter a lot of graphs. The ability to make use graphs in economics and it is as important as the ability to read and write economics. And that is why in this session we are going to look at different kinds of graphs that are used in economics, and we're also going to learn how to make them and read them. It's not just about sketching the graph. You should be able to read the graph, interpret the graph. So by the end of the session, we believe that you should be able to at least draw two variable graphs. You should be able to distinguish between many different kinds of graphs in economics. You should be able to calculate the slope of a straight line. How do we calculate the slope of a straight line? So let's get started with drawing a graph. So a graph is a visual representation. When we ask you the meaning of a graph, it is a visual, the keyword is visual representation of the relationship between, say, two variables. Looking at, if you are drawing a graph for two variables, the representation is going to be about the relationship between the two variables. And to construct a two variable graph, a graph can be three variable, and that one we have the Cartesian plane. That is the 3D dimension graphs are mostly with three variables. But here we are just going to be dealing with xy, just as we've been drawing or you've been sketching when you're in JHS and SHS. So to construct a two variable graph, we set two scales perpendicular to each other. So I'm going to have sketch something like this. All right. So I have my vertical and my horizontal. Now I can say let me write some numbers here. 1, 2, 3, 4, and 5. And I'm going to have 0 here. I can say here is going to be 5 CDs. I can say here will be 10 CDs. 10 CDs. Here will be like 15 CDs. 15 CDs. Alright. I can say this place will be number of movies. So you watch movies, then we charge you. Alright, so price per movie. So this side is going to be the price per movie. Alright. Okay, so the two scale lines in this figure, when we say the two scale lines, we are talking about the horizontal and the vertical, are called axes. This we have axis here. So remember, maybe SHS, you say this is the x axis, and then you say this is the y axis. So the vertical is normally called the y-axis, and the horizontal the x-axis. So that's what we are saying. The vertical is the y-axis, the horizontal is the x-axis. The 0 point common to both axes is called the origin. This part is what we call the origin. All right. Now we can identify the values of the two variables at the 2 points. Say, let me try and bring some dashed lines somewhere. So I'm assuming I say when you watch 2 movies, it is going to cost you 10 CDs. When you watch 4 movies, let me say I'll mark 4 to 5 CDs. I say here C, here is going to be, let's say D. Here will be D. Alright. Now, the two variables at the point C, this C, as 2 units on the x-axis and 10 units on the y-axis. Similarly, we can identify the values of two variables at point D as 4 units on the x-axis and 5 units on the y-axis. These numbers form an ordered pair which we call, let's say, x, y. X, y. This is the ordered pair called the coordinates of the point C. So I ask you to find the coordinates of point C. It's going to be what? 4 and 10. Where the coordinates of point D will be what? This is going to be 2, 10. Coordinate of point C is 2, 10. The coordinate of point D is 4, 5. Alright. So when we draw a line or smooth curve to connect these points, we get a graph showing the relationship between the two variables. And if the graph is a straight line, we say the relationship is linear. So what I'm saying is, assuming I connect this to this. So if I draw it to scale and the line is a straight line, we say the relationship is not linear. But if it's curved, you are not going to say the relationship is a linear relationship. Now, we are going to look at graphs used in economic models. Graph used in economic models. You will encounter many different kinds of graphs in economics. And there are graphs that show each of the following. The following we are talking about A, things that go up and down together. They go up and they go down together. And things that move in opposite direction. And the others that have maximum or minimum, let's say turning curve, something like that. And we also have things that are not related to each other at all. They are not related at all. So we are going to look at each of these four cases respectively. So we will start with the first one, things that go up and down together. Now, the relationship between two variables that move in the same direction is called a positive relationship. Such a relationship is shown by a line that slopes upward from left to right. Now I'm going to sketch it. I have my, let's say, my x-axis, my y-axis. My y-axis is here. We are saying that the line should be like this. Should be like this. Now with this line, we can see that let me indicate some numbers. Let's see, 1 2 3 4 5. 1 2 3 4. 1 to this, 2 to this, 3 to this, 4 to 4. All right, my origin is here. Okay, so this line, as x increases, you will see that y also increases, and as x decreases, y will also what? Decrease. So that is what we are saying, that they move in the same line. Both x and y move in the same line. We have different kinds of graph. Let me sketch another one. We can have it like this. We can have it like something like this, or we can even have it like something like this. All right, and I have my y here as usual, x here, y here as usual, x here. So they both move in the same direction. As y increases, x increases. As y decreases, y decreases. These graphs are normally called upward sloping. Call them upward sloping. We also have the downward sloping. The downward sloping, they move in opposite direction. Now this is upward sloping lines. Let's get to the second one where they move in opposite direction. We are going to talk about the downward sloping lines. Now, a relationship between two variables that move in opposite direction is called a negative relationship. Remember in this HS we see the demand curve is a downward sloping curve. It shows a negative relationship between quantity supplied and the price. We see that when prices goes up, quantity demand goes down. When prices are reduced, people demand more. But in terms of the supply, we see that for the supply function, the supply curve is positive. Let me repeat it: the supply curve is positive, but the demand curve is negative. So the first one, the first scenario, the A curve that we drew is more like the supply, but the B, this one that we have come to focus on, is more like the demand curve, whereby there is a negative relationship between quantity demanded and quantity price of the commodity. Sorry. Now we will sketch the graphs for us to understand. Now in this case, my graph is going to be like this, or I can have it like this, or I can have it like this. All right, I have my origin x y, origin x y, x origin my y. All right, now you can see that as let me bring some 1, 2, 3. 1, 2, 3. Now look at this. Look at this. Look at this. So assuming this is mapping to this, this is mapping to this, this is mapping to this. You see, when x is 3, y is what? 1. When x is 2, y is what? 2. When x is 1, y is 3. So as this is decreasing, it's like y is what? Increasing. But when y is also decreasing, x is what? Increasing. So the relationship is what? Negative. Now let's look at the third one. Third one, we are looking at economics is about optimizing or doing the best with limited resources. For example, making the highest profits or achieving the lowest possible cost of production. Now, economists actually make frequent use of graphs depicting relationships that have a maximum or minimum k. Let me try and sketch an example. I have something like this. This one is what we call the maximum curve. Maximum curve. The minimum is open upward. This is open downwards, open up. This is, let me write it, open downwards. This is opened upward, and that is the minimum curve. That is the minimum curve. Now we will look at the fourth curve that looks at the one variable where one variable is independent of the other. Now there are many situations in which one variable is independent of the other. No matter what happens to the value of one variable, the other may remain constant. Here you may hear about goods that are necessities. Okay, something like this. So they may tell you that salt is a necessity. So even when the prices are increased, consumers will continue to demand the same thing, and the value of X is the same. It doesn't change. Let me say X origin my Y. Here we say unrelated, unrelated. They are unrelated. They are unrelated. This is also unrelated. No matter what happens to y, x doesn't really matter. Here, no matter what happens to x, y doesn't really matter. Now we are going to look at the slope of a straight line. Now, the slope of a straight line is the ratio of the vertical change to the horizontal change. When we say ratio, something is to something. So let's say ratio of the vertical is normally by the y, so vertical change is to the horizontal change, that is the change in x. So when you see here, it's the same thing. In ratio, you can represent it in terms of fraction. This is the same as change in y over change in x. Alright. So the slope is a straight line, that is the ratio of the vertical change to the horizontal change between 2 points of a line. In other words, it is the change in value of y divided by the change in value of x. Let me circle this part. That is the thing. Now we use a Greek letter as we see here, this symbol, to represent the change. That's how come we have this change of y divided by change of x. I'm going to sketch a particular diagram for us to understand what we mean by change. Now I have something like this. I have my x, I have my y, I have my origin. Now assume I have 1, 2, 3, 4, 5, 6, 7. Alright. 1, 2, 3, 4, 5, 6, 7. Alright. Then I'll say 2 may map to 3. So let me my broken lines here. I have my 2 to 3. Then I can say the same thing for 6. Alright. Then I will come to 6 to 6, 6 mapping to 6. This thing. Then I will sketch this straight line here. Great. Now, when I ask you to find the slope of this, how do you do it? Now, the slope of this, remember, x change from 2 to what? 6. Yeah, so here depicts the what? change of x, change of x, and here change of y. All right. Now y also was like from 3 to what? 6. So I can, the arrow is like this. So the slope is going to be, as we said, this over what? This. This is the slope. All right. We can sketch another line. This first line is showing a positive slope. There is a positive relationship between x and y. As x increases, y increases. How about a negative one? Like we have here, a negative line. So I can have something like this, where this might map to this may map to this. I can say this will be 2, this will be my 6. Here I'll map to 3. Here I'll still map to 6. Remember, here is y, here is x. So here we see that x increased but y what? Decreased, right? So change in y, change in what? X. Now I'll name this diagram A, I'll name this diagram B. Take note of this. In panel A, this panel, this graph, this panel A, when x increases from 2 to 6, y increases from 3 to what? 6. Alright. So the change in x is going to be now 6 minus 2, which gives me what? 4. Alright. Okay, so the change in x is 4. And the change in y will be what? 6 minus 3, which gives me what? 3. This is change in x. This is change in y. Find the slope, which is change in y over change in x. We are going to have 3 over what? 4 as the slope. How about that of this panel B? Here, when x increased 2 to 6, we realize that y decreased from 6 to what? 3. So in this case, change in x was 6 minus 2, which is 4, but change in y was negative. The y2, normally we subtract the second value of, so it's y2 minus y1. The y2 is 3, the initial point of y was 6. Here we get minus 3. So for the slope of this panel B curve, that is the change in y over change in x. So we're going to have minus 3 over 4 as the slope. You can solve more examples on your own from the model you have for your textbook to understand things better. See you in the next session which talks about equation of linear function. Thank you.